So this is a problem from the homework 44B, number 43. It's a problem about using the mean value theorem for integrals. So we spent a lot of time on the mean value theorem, but when they say for integrals, they mean that one that's about area. So what happens is we know that there is some kind of magical value C on this interval from 0 to 2, where our area of a rectangle at C, so let's just draw a picture really quick. So mean value theorem would be like we have this curve and we want to know the area from, say, A to B, or we're finding that integral from A to B. And then there is going to be some kind of value C somewhere in there. It doesn't have to be right in the middle, but my area of that rectangle is going to be the same as the area under the curve. So that's what we're looking for. So my area under the curve is the integral. So first I'm going to find the integral so I know the value of that area. So let's see, integral from 0 to 2 of x minus 2x dx. Oh, sorry, 2 times the square root of x. This is a really ugly problem to try to understand this theorem. And so that's why I want to do this. So now I've got to go through and actually figure out the value of this. So if I have x to the first power, now I'm going to have an x squared over 2. This is a 1/2 power. So that means we're going to have x to the 3/2 all over 3/2. And we are evaluating this from 0 to 2. Let's see, if we have 2 divided by 3/2, what happens? That's going to be 2 times 2 over 3, so 4/3. So let's just tidy this up a little bit. We have a 1/2 x squared minus 4/3 x to the 3/2 power. Okay, now we're going to go ahead and substitute our numbers in. So we'll have 1/2 of 2 squared minus 4/3. So I want to think about how 3/2 power, that's 1 and 1/2. So that means I'm going to have a 2 to the first power, and I'm going to have a 2 to the 1/2 power, or a square root of 2 in there. Let's see, and then minus, got to plug in your 0, so we'll have 1/2 of 0 squared minus 4/3 times 0 to the 3/2 power. So this is just obviously going to be 0. Okay, so let's go ahead and simplify what we have. So this is going to give me 4, so 2 squared is 4 divided by 2 is just 2. And here I'm going to have 8/3 times the square root of 2. And I think this is going to be easier to work with if I just have like one fraction with all the stuff together. So we'd need to multiply the 2 by 3 over 3. And then I'd have a 6 here, right? This is what I'm doing. So then I'll have 6 minus 8 square roots of 2 all over 3. So I have a feeling that to have one fraction is going to be easier. So what we're saying is this is the area under the curve, right? And the area under the curve is going to be the same as the area of a rectangle somewhere at that magic value of C. So we're looking for an x that's going to make those areas equal. So let's go back and review again. If this is at C, then my y value is going to be f of C. And if I'm looking at the actual area of the rectangle, that would be my base. So my base is going to be b minus a, because that's the distance between those two. And my height would be that f of c. So what that means right now, and this is part of that theorem, you don't have to like derive this every single time. I did not mean to write an equal sign. It should be times. So my area of the rectangle is this, the height, times that base, the b minus a. And that's going to equal that area that we came up with, the 6 minus 8 root 2 over 3. So this is what I've got to figure out. So b minus a I know. That's from my interval. So this is going to be a 2 minus 0. So 2 times f of c is going to be 6 minus 8 root 2 all over 3. So I'm going to divide both sides by 2 or multiply both sides by 1/2. And what I notice here is if I factor a 2 out of the 6 and 8, let's see, that'd be 3 minus 4 square roots of 2 all over 3. Then I could divide the 2 out on both sides. So f of c is going to equal 3 minus 4 square roots of 2 all over 3. So at this point, I need to actually find c. So I'm going to go back and grab that function from the beginning. So let's remember f of x is x minus 2 square roots of x, and I'm going to go ahead and use this. I'll plug c in. So now I'm going to have c minus 2 square roots of c equals 3 minus 4 square roots of 2 all over 3. So this is a really ugly problem, and that's why I'm doing this as a video. So our issue is that we have c in more than one spot, and it's just kind of a mess. So looking at this, I'm noticing that if I took my square root of c and squared it, like this c right here is square root of c squared. And then my middle term is 2 times that. It's 2 times the square root of c. So it reminds me of a perfect square trinomial. So think about, instead of a root c squared minus 2 root c, what if I had just an x squared minus a 2x, right? This is x, so this one is that squared, this one's double. In order to complete the square, I'd have to add 1. Same thing with the square over here. I am going to add 1 on both sides. So it's kind of tricky. And when I add 1 on this side, because I want to add it into this fraction, I'm going to add it as 3 over 3. So now I'm going to factor on the left, because this is a square root. I'm going to have square root of c minus 1, the quantity squared. And so you might want to even go through and like multiply that out and make sure it matches, just to convince yourself. On the right hand side, I added my constants. And now I'm going to square root both sides. And when I have a square root of root, I get an absolute value, which really means I'm going to have a plus or minus here. And then I would want to add 1 on both sides. And I know it looks really ugly with a root inside a root, but remember, we just really don't want to have decimals until we have to. And then to get c by itself, I would square both sides. So we know that this has to be on that interval from 0 to 2, and it's tempting to think, oh, we need to throw out the negative, but we're squaring either way. So the two answers we're going to get out of this are going to be positive, but we should go ahead and just find the decimals, because it could be that they're not in that interval. And so if you use a calculator and we do 4 decimal places, you're going to get these two answers for x, and they are both on that interval. So we're going to keep both answers. And that's our final answer.